Hello everyone, in this video let's discuss about half wave rectifiers. If you are new to our channel, please subscribe for more engineering related topics. So half wave rectifiers will only rectify half of the input signal to DC signal, that is they rectify only one half of the input signal, that is only positive half cycle. They will only rectify positive half cycle. To build a half wave rectifier, we will use three major components, that is, so the three components are: first one is transformer. So here there is a transformer, so let's call this as P, that is primary coil, and S means secondary coil. So let's take V1, that is voltage 1 will be the voltage across the primary coil of the transformer, and V2 will be the voltage across the secondary coil of the transformer. Next, N1 is the number of turns in the primary coil, and N2 is the number of turns in the secondary coil. So we are using a diode right here, let's name it as D, and this diode and load resistance are in series. Both load resistance and diodes are in series. So the second important component is diode, and the third most important component is load resistor. Here V1, so V1 will be the source voltage. V1 will act as the source voltage, and V2 will act as the input to the rectifier. V2 will act as input to rectifier. So these half wave rectifiers will work in two conditions, that is during positive half cycle and during negative half cycle. Let's discuss about them. So first, during positive half cycle of the input wave, the diode D, so the diode D will be connected to positive. During positive half cycle, the polarity across the V2, that is the secondary coil, will change, plus and minus. So the plus is connected to the anode of the diode. So if you consider this as the diode, this will be called as anode part, and this will be called as cathode part. So here the anode is connected to the positive terminal, so therefore the diode D will become forward bias. When the diode D will become forward bias, it will conduct a current, let's call it as I. So it will conduct a current I. Therefore there will be the output voltage V out or V0. So therefore diode D will rectify the positive half cycle, diode D. During negative half cycle of the half wave rectifier, when the wave will be given as an input, therefore the polarity across the V2, that is secondary coil, will change. So this plus will become minus and minus will become plus. Now the anode is connected to negative. Since anode is connected to negative, the diode D will become reverse biased. When the diode will become reverse biased, there will be no output voltage. So the line will flatten. So it will not rectify the negative half of the input signal. So next, again positive half cycle, it will rectify. Next, negative half cycle, it will not rectify. Positive half cycle, it will rectify. Negative half cycle, it will not rectify. So the process will keep on going. Now let's discuss about some important formulas of the half wave rectifiers. So first one, V1. What is V1? V1 is the source voltage. What is the formula for V1? V1 is equal to Vm, that is maximum voltage into sin theta. Next V2. What is V2? V2 is the input to the rectifier. So V2 is equal to N2 divided by N1 into V1. What is N2 and N1? N2 is number of turns in the secondary coil. N1 is the number of turns in the primary coil. Here, if N1 is greater than N2, that is number of turns in primary coil greater than number of turns in secondary coil, means we will call the transformer as step down transformer. Step down transformer. If the value of N2 is greater than N1, then we will call the transformer as step up transformer. The current I, which will be produced during the positive half cycle because of the forward biasing of the diode. So what will be the formula for I? I is equal to Im sin theta. What is Im? Im is the maximum current. How to find Im? Im is equal to Vm, that is maximum voltage, divided by RL plus RF. What is RF? RF is the small resistance due to the forward biasing of the diode. Due to forward biasing of diode, there will be the production of small amount of resistance. It is called RF. So let's discuss about some characteristics of the half wave rectifier. So first one is efficiency. So the efficiency is output power by input power. The efficiency of the half wave rectifier is nearly 40.6%. Next, ripple factor. So the ripple factor of the half wave rectifier will be 1.21. So what is ripple factor? Ripple factor is the alternative current component present in the rectified output. So ripple factor is the AC component present in the rectified output. Hope you understood the half wave rectifiers. If you have any doubt, please comment below. If you like the video, please subscribe. Thank you.